Today, I would like to take you all through the evolution of light theory. It was Pythagoras who put forth the particle theory of light. Pythagoras believed that beams of light were made up of tiny particles and that the eye could detect these particles and see the object. By 1000 CE, scientists started to understand how to manipulate light to improve vision. Reading stones were developed to magnify letters using the properties of light. This led to the invention of lenses. The first spectacles came into use when people put these lenses in a frame. In late 1500s, Zacharian learned how to magnify objects more and invented the first microscope, which was used to see really tiny objects. It was again modified and telescope was invented by Galileo in 1600s, which was used to see objects from a far distance. The wave theory of light was suggested by Huygens in the late 1600s. A wave is a disturbance or movement that transfers energy to matter or space without causing any permanent displacement. A wave consists of crests and troughs. Wavelength is the distance between two consecutive crests or troughs. There are two types of waves. One of them is transverse wave. In a transverse wave, matter in the medium moves up and down perpendicular to the direction that the wave traveled. The second type of wave is a compression wave. In a compression wave, matter in the medium moves back and forth along the same direction that the wave traveled. Light waves are transverse waves, and sound waves are compression waves. Now I'm going to talk about properties of visible light. Visible light is a wave you can see. If the light wave is traveling at an angle and the speed that light travels is different in the two mediums, the wave will look bent or refracted. Refraction is the bending or changing of direction of a wave as it passes from one medium to another. Example, pencil in a cup of water. Following refraction comes reflection. Reflection happens when a light wave strikes an object and bounces off. When a light wave passes through objects like prism, it breaks into different components or colors. Just like that, in a rainbow, the human eye can distinguish a range of colors that are often described as falling into 7 broad categories. In order of decreasing wavelength and increasing frequency, these colors are red, orange, yellow, green, blue, indigo, and violet. This range of colors or frequencies of visible light is called visible light spectrum. Like the visible light spectrum, there is an electromagnetic spectrum, which is the range of all possible frequencies of electromagnetic radiation. An electromagnetic radiation is the transmission of energy in the form of waves that extend from the longest radio wave to the shortest gamma rays with respect to wavelength. The electromagnetic spectrum consists of radio waves, which is useful to listen to music, microwaves, which heats your food up so you can eat, infrared waves, which helps you operate remote control, ultraviolet wave, which gives you vitamin D, X-rays, which help doctors check if your bone is broken, and in the airport it helps you scan luggages. Gamma rays, which help kill cancer cells and other cells. Now that we all know light is important in our life. Thank you. I hope you enjoyed the film.